now that my iron is heated up, I'm going to take a little bit of flux paste and apply it to that. You don't have to be so deliberate. I'm just trying to be neat with it. Again, you don't have to. You can just glob it on there. Yeah, there you go. You just glob it on there. So now, what you want to do is you're preparing the pad here to receive something like a wire or a component or something like that, and this is a pad from factory with no tin on it already. So you're gonna be tinning the pad. I've fluxed it to clean it for the first time, and then I hit it with the iron to melt the flux, and then I put a little bit of solder on, let the iron linger for a moment, and then that's a perfectly tinned pad. It's got some flux still around it, so that the next time it's heated up, it can reflow the solder in the presence of flux, which is very handy. And now next, we're going to prepare our wire. This wire, I already had the ends trimmed, stripped, and I tinned them already, so we are going to undo that. I have a set of fine wire strippers, and I'm going to use it to cut the ends. Now I know this to be 28 gauge because I just measured it with these. So, just a rough way of how I determine sometimes if I forget what the actual size of the wire is gauge-wise. So, just slot it in the biggest, doesn't work. Next one doesn't work. This 24 starts to work. 26 works a little bit better. 28 worked the best. And 30 started to take off, because this is a braided wire. 30 started to take off some of the braided core, like strands, is what I mean to say. It took off some of the strands. So now what I'm gonna do is, to prepare this to be tinned, I'm not using my fingertips, so I don't have any grease, finger grease, which is a pretty bad thing to introduce to the wires. And you're gonna be soldering to and such. But I twist the ends just to confine all of the strands. Then I just dip the bare metal end in flux. And that's it. Now, I'm gonna let this go. I'm going to use this to hold the wire. Just to make it a little bit easier. And now what I'm going to do is I'm going to take my iron, I'm going to clean the tip a little bit, I'm going to tin the tip, and then I'm going to place that tinned tip to the wire, melting the solder and the rosin together, and that is how I tin the tip. And then I'm just gonna flip that over, and now we have the other side presented. do the same thing. I'm gonna let this liquid solder melt the rosin, introduce a little bit more solder, and that's how I tin the tip of a wire. Now, we'll drop the wire, and we will go back to bracing our work. Then, if you'd like, you can dip the end of this wire in flux. But you don't really need to, because there's a lot of flux around the area that you're going to be soldering to anyway. So I freehand it because I've kind of developed a steady enough hand, and then I just place the tinned tip of the wire on top of the tinned pad, and I just lay the tip of the soldering iron on top until everything melts together, and then I remove the soldering iron, and we're soldered. And I'm tugging on that wire, and there you go. That's how I solder wires, the joints. And I will get a close-up with the macro lens of what this looks like, just so you can see what a half-decent solder joint looks like. And I think I did a half-decent job there. So bear with me one moment here. There is a close-up shot of my of my wire soldered. And after talking all that shit, turns out to not be the best solder joint ever. So we're gonna go ahead and see if we can't just touch that up while we got the macro lens going on. So forgive me for the shakiness that's about to happen. Alright, so I am going to apply a little bit of flux here. Just a little bit. Just the tiniest little sloppy glob. Whatever, it's gonna get anywhere. Anywhere I touch. Okay. So, I've got the tip of my iron tinned, and I'm tugging on the end of the wire. So I'm just going to heat this up and desolder it real quick. There we go. And now I'm going to solder the end, tin the tip, remelt the solder, and flow a bunch more. Now I've got a ridiculous solder blob there. That is not good soldering practice, but can easily be removed by just sliding the tip of a hot iron over it, melting it, and carrying it away, or spreading it to the next pad, which is why that's not a good method, because if you didn't want solder on this next pad, well, now you're fucked. And after all that, I gotta add a little bit more solder because I wiped it all off. Alright, there we have a more manageable solder blob. Now I'm going to lay the end of the wire down. Ew. See the debris? Wouldn't have seen this if it wasn't under magnification. So I'm gonna go ahead take that off with my fingers. All right, now we're back. You see the tip is tinned, and we've got a bunch of flux around, so we won't be dry if we're quick. So I've got my tip, and it's still tinned, and I'm just going to pretty much press it against this wire, melting the wire's flux and solder, and that causes the pad solder to melt, and the wire sinks right in. Not the neatest job on that one. I'll just move the wire over a little bit, and good. So let me brace this with my hand, and ever so not gently tug at that wire. All right. That's a half decent solder joint. It's definitely conductive. It's definitely reliable, but it definitely could be better. The solder itself looks great. I am going to get a little bit of alcohol on a Q-tip, and if you can see that splatter pattern, that's the flux. So we're gonna try to take all of that off. All of that could potentially cause corrosion. So alcohol on a Q-tip. Just for the sake of seeing. Oh yeah, there's still a lot around the edges. See, and all of that was left behind by alcohol and a Q-tip. You can see just, this was a clean toothpick that I used. All right. That is a damn good joint. The wire's centered. It's not around the edge anymore. I can still tug it so hard that the wire snapped. Hold on. The wire snapped almost clean off. It became so strong of a connection that this became the weak point. Cool. Next, we will do component. This is a bunch of 1N4148 diodes. They are through-hole components, and this is also a really good opportunity to show you some old parts that may not be easy to solder in place as they come. So first, I'm just going to clip one free. And in my haste, it appears as though I have lost that part because I did not brace it. Did not brace it with my finger as I cut it. So, try that again. There we go. Bend it out, cover it with my finger, cut it, and now I've got it. Hooray! So, this part is pretty gnarly looking. It's got corrosion, or at least some form of weathering. The metal's not shiny, it's all pitted out. And it's probably gonna have a hard time accepting solder. I just kind of found some sandpaper. So I don't really know what grit it is. I don't even know how to describe how it feels in comparison to other, because I don't use sandpaper for anything really. But this, I want to say it's a fine grit, but I'm sure there are worlds of finer sandpaper out there, finer grit sandpaper out there. So I'm just going to take it and I'm going to fold it sandy side in, and I'm going to rough up the legs of this component. So, if you go real far, you'll actually be taking off a decent bit of metal with this grit of sandpaper. So, in retrospect, I should have just wipe both sides, because this doesn't seem like it's that fine in this context. So, I am going to rebrace my work here. Actually, no, I'm gonna unbrace my work here. What I'm gonna do is I'm going to say that we are going in this hole here. All right, so we are just bending the legs of the component so that they will fit into the desired circuit. And with this, I'm just going to cross a nice gap. So we've got the component through the board, and I'm just going to make sure that it's nice and flush. And then I'm going to bend one leg so that, well, I'm going to bend both legs so that when I tip it over, my work doesn't, well, the component doesn't fall out of its position. Then, instead of working with it up, I have the luxury of working on the bottom of this board. Okay, now I am going to apply a little bit of flux to both points that I'm soldering to, just so that as I'm first hitting it with heat, the area is being prepped to receive solder, because this is all factory fresh through holes. So I'm tinning my tip, I'm touching the tip to the through hole and the component, and then I'm putting solder in between the two and taking it away. And then the same applies for this. All right. So that's soldering a component through a board. Now, let's check that work. Let's unplug this fan. No longer need it. So now we look half decent on the other side. That's a bit much solder, but it just kept falling through. And that looked great. Both of our solder jobs look magnificent. So what I'm gonna do is, again, the ends go flying, so I'm gonna trim this, try to flush, put my finger on that end as I cut, so that it doesn't go flying. And I like to keep all the ends that I trim off of these components, because I can use them for shunts or other projects, jumper wires, or very, very many other things. All right. So surprisingly not sharp and pretty flush to the board. We have one soldered in component. Next, we're going to do a bit more complex of a part. We are going to solder in a rotary switch that I took off of that Line 6 Pod 2. All right. So this is the rotary switch that I took out of the Line 6 Pod 2. And we are going to solder that in. So I am going to use an alligator clip to keep that in place. Like so. All right, so now I'm just plugging in the fan. There we have it. And we are going to ever so lightly flux each point. Cool. Now, I am going to tin my iron, hit this first pad, melt the flux, and solder it in. And then I'm just going to repeat the process with each pin. Okay. Now that is completely soldered in place. Unplugging my fan. So we've got them wired in, no, soldered in. And if you really want to, you can trim those, but I don't want to, because I'm just gonna take it right out of this board. But I wanted to get a nice close-up of all of these solder joints, because there's a few that look great and a few that don't look so great, but none of them are bad. So I'm gonna try to do that. Well, this calls for flux. I'll try just a tiny drip drop of flux for both of them. Then we will tin our tip with some fresh solder. That's pretty much soldering 101. Soldering wires to pads, soldering components to board with through-hole components. So I'm just gonna melt some solder onto the tip of my soldering iron now that it's off and almost cool. And I'm gonna put it away with solder on its tip. And that's the last step, really, other than cleaning up all of that flux. And you saw how hard it can be sometimes to clean flux, but these boards are durable. If you have an old toothbrush and some isopropyl alcohol, you will not knock off components for the most part unless they were ready to go already, in which case either work on soldering better or you probably missed something when you were repairing that board, because that piece shouldn't fall out like that if it does. Anyway, I am going to call it there for now. I'm going to start in on my Game Boy mod and see if I can't edit something down from that. Well, until then...